This is a bounds question involving compound measures, in this case the density of a block of metal. So let's have a look at this one. It says that a metal block has a mass of 5 kilograms to the nearest 50 grams. Note the difference of units there. The block has a volume of 1.84 times 10 to the minus 3, so they're using standard form, meters cubed. Correct to 3 significant figures, and notice that this number already is to 3 significant figures. Work out the upper bound of the density of the block. Give your answer in kilograms per meter cubed. Correct to 1 decimal place. Show you're working clearly. The best way of approaching any bounds question is to look at the units and the numbers that you're using, and just work out the bounds for each of the ones that you're using. So we're going to focus on mass to begin with. Now with mass here, we have 5 kilograms, but it's to the nearest 50 grams. So let's work in grams. That'll make our bounds a lot easier to do. 5 kilograms is 5,000 grams. Now I think a nice approach to do any sort of bounds question here is to think of it on a number line. So I'm going to put 5,000 grams on my number line. Now the bound above it will be 50 grams more, because that's the next number. So we have 5050 grams. And the one below, take 50 grams off, we get 4950 grams. So just to reiterate this, what we have here, we have 5,000 grams to the nearest 50 grams. So the next value it could have been is 5,050, or the one below will be 4,950. Now a common mistake is to think that these are the bounds. No, these are the numbers that you would have been rounded to if it was closer to this. So we need the halfway points. That will be the bounds here. So we need this mark and this mark. The one below is halfway between 4950 and 5,000. So that will be 4975 grams. That's our lower bound. And then the upper bound is halfway between 5,000 and 5,050, which goes here. And that's going to be 5025 grams. And that's our upper bound. That's all I'm going to do with that for the moment. We're going to look straight now onto volume. So the volume is written as 1.84 times 10 to the minus 3 meters cubed, and it's correct to the nearest 3 significant figures, so that number is within 3 significant figures. Again, I'm going to put it onto a number line. So 1.84 times 10 to the minus 3. The one above it would be a number that is to 3 significant figures, but the next one along, so it's 1.85 times 10 to the minus 3, and the one below will be 1.83 times 10 to the minus 3. Now the lower bound is halfway between the first two, so it goes to an extra significant figure, 1.835 times 10 to the minus 3. That's the lower bound, and then the upper bound is between the top two numbers there, so it's going to be 1.845 times 10 to the minus 3. These are all meters cubed, and that's my upper bound. So just take a moment to reflect on this. If we look at the mass, my lower bound is 4 figures here. It goes to it goes to one more place than the significance. So if it's 50 grams, we're doing plus or minus 25 grams. With the significant figures, my lower bound and my upper bound are to 4 significant figures, because these are the boundaries between. Anything in this region here rounds up to this one, anything here rounds to this, and anything down here rounds to this. So you can see clearly anything between here and here, if we rounded it to 3 significant figures, would always go to here. So I have my mass, my volume. I've now already got a mark from the examiner because I've shown a correct bound. In fact, I've got 4 of them. So let's just make this a little bit smaller on the screen so we can see the rest of the question. Now the question asks for density, and it asks it in kilograms per meters cubed. Now say you don't know or you cannot remember the formula for density. Always with compound measures, just look at the units for the answer. If density is to be written in kilograms per meters cubed, kilograms per meters cubed is kilograms divided by meters cubed, which is mass divided by volume. That's my density. So you can see that the formula is always shown in the units. Now I have to be careful because I want the units in kilograms and meters cubed. I have my mass in grams here, so I need to be very careful. Now I want the upper bound. That means I want my fraction for my mass divided by my volume to be as big as possible. For that to be the case, I need the biggest number on the top, so that's the upper bound, and the lowest number on the bottom to be my volume, to be my lower bound. So that would give me the biggest possible answer. If I had them reversed, I would have a smaller answer. You can just try the different numbers if you wish, but just think of it logically. For a fraction to be as big as possible, the top needs to be as big as possible, and the bottom needs to be as small as possible. So I want the upper bound of the mass, so that's this figure here, and I want the lower bound of the volume, which is this figure here. My upper bound of the mass I need to turn back into kilograms because that's the units I need. So 5.025 grams is 5.025 kilograms. So my density, my upper bound density, is equal to 5.025 divided by 1.835 times 10 to the minus 3, which when I do that onto a calculator, just put the calculator onto the screen, there, I'm going to get the answer of 2738.419, and it carries on. Let's check the question. The question says to one decimal place. So it's going to be 2738.4 kilograms per meter cubed.